Good morning, class. Today we're going to do lesson number 21, and we're going to look at what we are currently doing to help the climate and what technology we're looking to develop that's also going to help the climate. So let's start with energy today. So around the world, we use coal, natural gas, hydro, nuclear, solar, wind, biomass, oil, and a little bit of geothermal energy to power the world. So this is all the sources we use that are going to produce energy. The majority of the source that we use the most is going to be coal. Now, coal is the cheapest source to create energy, and it requires the least amount of foundation. So you could use coal to produce energy anywhere in the world. So a bunch of the countries that don't have the foundation to use nuclear power, or like some of the newer sources of power or sources of energy, will mainly use coal. So 41% of the world uses coal, 22% of the world uses natural gas, 16% of the energy comes from hydro, 11% of the energy comes from nuclear power plants, and then 6% come from a combined source of solar, wind, geothermal, which is like heat from the earth, and biomass, which would be like burning wood. And then 4% actually comes from oil, so burning oil. So that'd be kind of like fuel. So again, coal is the one we use the most because it's the cheapest. But on this table here, we can see for each kilowatt hour of energy, so that's just like a unit that we use to figure out how much energy someone can produce or how much energy you're going to use. So kilowatt hour is a general unit for energy. So for each kilowatt hour of energy, how much carbon or how much CO2, sorry, these sources will emit. So coal is by far the worst, emitting 1 kilogram of CO2 for every kilowatt hour. Where we get to natural gas, only uses 0.2. Hydropower uses 0.01, so that's 10 grams or 0.01 kilograms. Nuclear actually produces the least amount of CO2 at 4 grams. Solar is 50 grams. Wind is 34 grams. Biomass, that's like burning wood, that's going to be 38 kilograms or 0.38 kilograms, so that's 380 grams. And oil is kind of in the middle at 0.26 kilograms or 260 grams. And it depends what kind of oil you're burning. It can be a bit more, a bit less. I just averaged it. So there's no perfect source of energy, not right now anyways. Some are dangerous or appear dangerous, while others will be expensive, and some are unreliable. So hydro is pretty good, only emits 10 grams of CO2, so it's the second lowest. And it's great when you have the resources to do it, or you live in a place where you can have hydro. So in BC, we're very fortunate to be able to have hydro energy by having dams built and having hydro power plants. So hydro is good for the environment, or for the atmosphere anyways, but having a hydro power plant destroys the habitat of animals that live around it, and can even change the weather, leading to more droughts because we're blocking off natural water, how water naturally will move, and we're creating a dam so we can harvest the energy from the water falling down. So because the gravity wells don't fall down, so we harvest the energy from the water. So it's good for emissions, but isn't great for the environment around the power plant. And also you have to be able to have a dam. So if you're in like the desert, you're not going to be able to use hydro power plants because there's no water around. So hydro power plants are good if you can have them, but they're not so good for the environment around them. Next, we can look at solar and wind, and they're pretty good. They only emit about, on average, between them, about 40, 42 grams of CO2 per kilowatt hour. The problem is solar and wind power is expensive right now. The technology we have is quite expensive. So if you were to buy your own solar panel, right now it will not pay for itself. It's cheaper to get energy from the grid, as well as they're unreliable. So if it's a cloudy day, you're not getting any energy in. And you can store the energy, but we currently don't have the technology to store like a year's worth of energy. So if it's not windy, you can't get as much wind energy, or if it's too windy, the wind turbines won't, they'll break. So you have to like shut them down. So it's only sometimes that you can get um, solar or wind energy. So they're not always around. But with new technology coming out, uh, there are some clever ways to fix this problem. So like there's new wind turbines that are coming out that will actually point in the direction of the wind, so they'll rotate. So getting they're maximizing the amount of energy they get. And then if it's too windy, they'll fall down themselves. So new technology coming out, and they are improving, but currently right now they're more expensive. Um, I think they're the most expensive energy to produce, which in today's culture, I guess you call it culture, isn't viable. We won't. We're not at the point where we're going to spend money just to be environmentally friendly as a society. I guess that'd be the right word, society. Um, so next, we can look at nuclear power. So nuclear power, this is where it's pretty interesting for me. So we currently have technology to get energy from nuclear fission. So fission is when you take a big atom, so like uranium, and you break it up into two smaller atoms. And as it breaks up, it produces energy. So the atoms that produce the most energy are going to be radioactive atoms or radioactive elements. And the byproducts they give off are also going to be radioactive. And the byproducts are the big problem because a lot of the time we don't know what to do with the byproducts. So they just sit, and that's like nuclear waste. So we get our energy from the uranium. I think there's another radioactive material. I forget the name of it. And the byproducts, most of the time, we can't do anything with them. As new technology comes out, we're finding ways to use the byproducts at nuclear power plants in like cancer treatments or in medicine. So that is great. And there's actually one power plant in Canada, a nuclear power plant, that is the only place in the world that produces a certain byproduct that is used in medicine. So that's pretty cool. So nuclear power plants are very, very good for the environment besides the nuclear byproducts. So if the byproducts are stored correctly, like radioactivity is not unnatural. Things are naturally radioactivity. So it's not like these byproducts are unnatural. These elements are still are found in nature. It's just when you get a bunch of them together, it can be bad for the environment. So as long as the byproducts are stored correctly, which can be expensive, so sometimes they're not stored correctly, nuclear power plant is very clean energy. But it can go very bad. So, like the incident at Chernobyl, or at the nuclear power plants in Japan when there's the big tsunami. So they have the chance to go very bad. Before you get into the next paragraph, if we look at like coal, natural gas, oil, or biomass, so like burning wood, these energy sources are cheaper to use, but they're terrible for the environment. So that's kind of the downside of them, is they're not good for the environment. They're producing a lot of CO2, which is what we don't want to produce. So again, CO2 is like the main problem with climate, is the main cause for climate change, for producing so much CO2. So back to nuclear power. In the future, we're looking to get to nuclear fusion. So nuclear fission is when we break an atom up into two. Nuclear fusion is actually what's happening in the center of the sun. You take two atoms and you put them together to form a bigger atom. And this produces a lot more energy. So the way it works, if you take two atoms and you squish them together and the atoms both are lighter than an iron atom, you're going to produce energy. If the two atoms are heavier than an iron atom, you're going to gain energy by breaking them up. So it's like the energy gain is like this, and you get to iron, and then it starts to fall with heavier atoms. So that's kind of, I guess I didn't really explain it perfectly, but that's getting into like some quantum mechanics there, so I won't go too far into that. So if we can take like two hydrogen atoms and squish them together and get helium, that's going to produce about 100 times more energy than splitting one uranium atom up. And the benefit of this is helium is fine to have around. We have helium everywhere. So the byproducts are perfectly fine, and we can actually use them. We can blow more balloons up because we're actually running out of helium on Earth. It's actually a small problem we have, that we're running out of helium. But if we're producing helium from hydrogen, well, that's great. And we're going to gain a ton of energy, and it's much cleaner. Now, it could have the chance of going worse than Chernobyl, but if we can do it properly and safely, this could be very close to perfect energy source, or the most perfect that we could foresee anyways currently. So that's kind of energy. Um, so really the big thing, I guess, to wrap it up would be that 41% of the energy we use on Earth is the worst form of energy for the environment. And we use it because it's cheap and it's easy to use. Um, so we must push to get cleaner energy sources. Even if it costs a bit more, we have to find a way to stop using coal. Because if you look at the graph of it, coal produces by far the most amount of CO2. And it is a massive problem that we're using so much coal. And BC, actually, we produce a lot of coal. We don't use it, we ship it off, but we have a lot of coal in BC. We have a lot of very good coal for very, very hot. So we are part of the problem. All right, so on to food. So this one's interesting. I'm going to talk about lab-grown meat here. You could have a wide range of stances, and with lab-grown meat, maybe I'll explain what it is first, and then we'll talk about it. So lab-grown meat is essentially you take a muscle sample from an animal, so let's say like a cattle, and you take the cells, mostly stem cells, from that muscle sample, and you use that to grow more meat. So it's like you take these cell samples, you put them in a petri dish, and essentially you grow them. That's very, very simplified, but the cells sort of multiply, and it's like growing a baby, but you're not growing a baby, you're just growing a slab of meat, because those are what the cells are. Those are like cells for muscle, so you're just going to grow a slab of muscle, a slab of meat with no brain, nothing like that. It's just like a slab of meat. So the goal, or the reason that lab-grown meat is a thing, is because cattle, well, couple things. Partly because cows, produce so much greenhouse gases. So for 1 gram of beef you eat, that's going to be about 220 grams of CO2 or methane gas in the atmosphere. So 14.7% of all the world's greenhouse gases come from livestock, and most of that is from cows and cattle, because out of all the animals that we eat, they produce the most greenhouse gases. So if we can do lab-grown meat, we're not going to produce as many greenhouse gases, as well as we can produce, theoretically, a lot of meat in a smaller space. And then we can talk about maybe the biggest benefit is that it would be cruelty-free meat. Well, almost cruelty-free. We still need to take a muscle sample, but about one tissue sample can make about 10,000 kilos of lab-grown meat. So it'd be very, very few animals would be getting hurt or would be dying because we're wanting to eat them. So maybe the biggest benefit of lab-grown meat would be that it's cruelty-free. But then there's also the issue of, is lab-grown meat what people want to be eating? So I won't really talk about that too much here, just because I feel like that's a topic for a different class, or if we had more time, we could discuss that. But essentially, lab-grown meat right now, for beef, we only actually reducing the greenhouse gases by 70%. And that's because to grow meat in the lab, you need a lot of energy. And right now, our energy sources are not perfect. So if we are able to get much cleaner energy sources, then lab-grown meat would drop off in greenhouse gas, the amount that it emits, a lot more. So currently, it's still better to eat chicken or plant substitute over lab-grown meat. As well, right now, about 0.1 kilos of lab-grown meat costs about $500. So that's not great either. Not really a thing that everybody's going to buy at the grocery store. So yeah, so if we are able to stop eating beef, the cattle population will theoretically decrease because we don't need as many cattle, and that'll drastically decrease the amount of CO2 that we put in the atmosphere. Yeah, so lab-grown meat is more of a futuristic idea than a currently right now idea. But it could be a way that we could still eat meat, but have a benefit on the environment. So looking at fuel, so maybe I'll just stop the video here. I'll make a second part. I think it's going to go a bit too